This is the video I promised about a week ago. What you are looking at is the tip of a medium gutta percha point peeking about 1 millimeter out of the apical end of a root that has close to a right angle bend in it. This canal was quite tight to begin with. You see it here after it has been shaped 1 millimeter beyond the constriction to a 25, shaped to the constriction to a 35, 1 millimeter short of the constriction to a 40, and overlaid 1 millimeter beyond the constriction to a 25/06. I am now rotating the apical end of the tooth so you can see the round apical preparation we created after going through the above sequence of instruments. When I prepared this canal, I thought it was about as clear an example as one could hope to achieve to demonstrate distortion-free shaping using mainly relieved stainless steel reamers, either with a tight watch winding motion or in the 30-degree reciprocating handpiece. As long as the canals are kept free of impacted debris, the canals will remain patent and not deviate from the original pathway. Please note that the minimal apical preparation is a 35, a dimension that in the circumstances of this tooth could not be achieved with rotary nitide without major concern for instrument separation or straightening to the outer wall due to nitide's property of shape memory. As the tooth is rotated, we clearly see the right angle configuration of the canal. Here I am demonstrating the tight manual watch winding stroke applied to the 25 relieved reamer. A 30-degree reciprocating handpiece could have been used just as well. Here you can see the pre-fitted gutta percha point adjusted for length at the terminus of the canal. Here is another angle showing the placement of the medium gutta percha point with tugback. I thought it would be interesting to see the instruments as they appeared when removed from the canal after using a tight manual watch winding motion, reciprocation, or both. Due to minimal rotation, there is virtually no chance that any instrument will separate. It is also important to note the recording of the canal curvature in the stainless steel shaft of these instruments. The 25 went 1 millimeter beyond the constriction. The 30 goes to the constriction 1 millimeter shorter than the 25. The 35 goes to the constriction also 1 millimeter shorter than the 25. Note that because the shaft of the 35 is stiffer, it doesn't record the curvature of the canal to the same degree as the thinner instruments. While a stiffer instrument therefore has more potential to distort to the outer wall, the reciprocating motion minimizes the potential, as is evidenced by the perfectly round apical shape resulting from the sequence of instruments. The 40 is even stiffer, but it is used 2 millimeters shorter than the 25, again minimizing its distorting potential. I might add that although the canal displayed a close to 90-degree curvature, it was a subtle one, not abrupt, which allowed the instruments to all negotiate to length without the need for any pre-bending. The 25/06, not shown here, went 1 millimeter beyond the apex without resistance. The space created by the sequence allows for adequate irrigation and the placement of sufficient cement that, when coupled to a single medium, well-coated point, produces an excellent seal along the length of the canal.